Okay, slide ಕಾಣ್ತಾ ಇದೆನಾ? Okay, right. So I'm going to talk about interference. As you can see in the heading, it is interference is the topic, and as you can see, this is the first session. This interference has been divided totally into 18 sessions, and this is the first session of interference. In this session, we are going to cover the introduction about interference. So here we will be discussing the introduction to interference, what exactly interference is all about, and we will be discussing the types of interference, and we will be discussing what are the conditions required to obtain interference, and finally we will be talking about what is called coherent sources. There are something called coherent sources which are very much essential for interference. We will discuss what are these coherent sources, right? So what are the learning objectives of this session? The learning objectives are, we want to know what is exactly interference is, why it is required, and what are the types of interference, and if at all you want to have interference, what are the basic conditions required to obtain interference. So we want to know those things, and we also want to know what exactly the coherent sources are. So these are the objectives of this session. We'll learn these things in this session. Next, the session outcomes. That is, at the end of this lecture or this session, we should have the knowledge of interference. We should know what exactly interference is all about, and we should be knowing the types of interference, how many types are there, and we should be knowing what are called the constructive and destructive interference. The two types of interference, constructive and destructive interference, and what is the difference between constructive and destructive interference. You should be able to know what is the difference between constructive and destructive interference. And you will also come to know what are the requirements, the conditions in order to obtain interference. You will be able to understand this, and we'll get the knowledge of what are called coherent sources. So at the end of this topic or this session, you will have the knowledge of all these things, right? So this is the topic of discussion today. We'll discuss them one by one, right? So there are some prerequisites. In the sense, to understand this topic, you should have the knowledge of what is called optics. Then you should know what is geometrical optics, and you should know what is called physical optics. Let me explain them in brief. What is optics in general? We say optics is the branch of physics which deals with the study of properties of light. So optics is a branch of physics which deals with the properties and the phenomenon related to light. That is what is called optics. So optics talks of the phenomena related to light. Then there are two classifications of optics. It is classified as a geometrical optics, and it is also classified as a physical optics. So what is geometrical optics? What is physical optics? Geometrical optics deals with the properties of light in terms of what is called rare nature of light, in terms of what is called ray nature, or what is called the rectilinear propagation of light. Or in other words, in geometrical optics, we will be discussing about the topics like Fermat's principle, reflection, refraction, reflection at plane surface, reflection at curved surface, refraction, Snell's law, If you remember, all these things we have discussed in the last semester. In the last semester, we have discussed Fermat's principle, Snell's law, reflection at a plane surface, curved surface, refraction. That all comes under what is known as this geometrical optics. Here, we will be talking about the ray nature of light. Means light is treated like it travels in a straight line. So once you say it travels in a straight line, all the properties related to rectilinear propagation of light, like reflection, refraction, Fermat's principle, Snell's law, they all will be dealt in geometrical optics. Then, in this semester, we will be studying what is called physical optics. So what is physical optics? So physical optics is again a branch of physics which deals with the studies related to light. So here we will be talking about the so-called wave nature of light. We'll be talking about the wave nature of light. So here we're talking about the ray nature of light, rectilinear propagation. Here we'll be talking about the so-called wave nature of light. Means once you say a wave nature of light, the phenomena like interference, the interference phenomena, the phenomena like diffraction, the phenomena like polarization, right? These things will be discussed in what is called physical optics, where we say it deals with the properties of wave nature of light, like interference, diffraction, polarization. All these phenomena can be explained only if you consider light as a wave. Therefore, we say physical optics is all about the wave nature of light, whereas this is all about ray nature, or you can say the so-called particle nature. We call it as the particle nature, where we consider light made up of a number of particles. So this is about particle nature, this is about wave nature. So from this, what is clear? It is clear that light is having the dual nature. Sometimes it behaves like a particle, sometimes it behaves like a wave. Or in other words, some phenomena can be explained by taking light as a particle. Some phenomena can be explained by taking light as a wave. Right? So this is some knowledge of what is called optics, what is called geometrical optics, what is called physical optics. So with this knowledge, now we try to understand one of the very important phenomena of wave nature of light, that is what is known as the interference. What is known as interference. So we'll try to understand what is this interference is all about in this session, right? So let's discuss about the introduction to interference. What exactly interference is all about. You have seen this image in nature. You know what it is? It is what is known as a so it is a soap bubble. You might have observed in your real life a soap bubble. So if you observe a soap bubble, and if you look at from the different angles, if you look at from this angle, you get some different colors. If you look at from this angle, you observe some different colors on the soap bubble. If you look at from this angle, you observe some different colors in the soap bubble, right? So why we are able to see different colors from different angles in a soap bubble? The fundamental reason behind this is the phenomenon of interference. It is the interference which is taking place all over the bubble. There is what is called interference happening at two different layers of this bubble. One is interference due to reflection, one is interference due to transmission. We'll discuss them later in detail, but right now you remember that the appearance of different colors from the different angles is due to interference. So because of interference, we are able to see a beautiful colors in this soap bubble from different angles. I hope you are familiar with these things. If anybody has not observed such things, please observe it today. But what is necessary is you have to have this soap bubble in sunlight. If you sit at home and try to do it, you will not be able to see the different colors. this bubble should be exposed to sunlight, means there should be some light falling on this bubble, then the light undergoes interference and you'll be able to see these beautiful colors on the bubble. This is one classic example of interference. Then, so see here, we have some beautiful pictures. This is again that of the soap bubble, which I just told you. You know, the soap bubble example. This is the soap bubble, which you can experience if at all you are not come across. Definitely, I hope you are familiar with this bubble. In the second picture, have you seen these things? Definitely, you might have seen. You know, in your early days when you were in a primary school and all those things, we used to keep these, you know, the feather cock of peacocks in the books, and we used to tell so many stories. Do you remember them? So these are all the peacock feathers. If you observe these beautiful colors, in this peacock, and if you observe it from this angle, and if you observe from this angle, you'll be able to see different combinations of light. As you change the angle, you can see different color combinations of this peacock feather. So this is again due to interference. You know, this layer acts like a thin film, and there is an interference taking place. Whenever the light falls on this, there is an interference taking place on this thin film of this peacock feather. And once it undergoes interference, you are able to see different colors from different angles. A beautiful thing which is available in nature. It is mainly due to interference. If at all you are not observed, please do observe these things at home whenever it is possible. You can see the wonders of nature. As a science student, you should know what the reason behind that. The reason is, as I told you, it is interference of light. So here also it is interference of light. Here also it is interference of light. And you can see this, butterfly. As you can see the different colors in this butterfly. Again, if you see from different angles, you are able to see different color combinations on this butterfly. Why you are able to see different colors? Again, this layer, the upper layer of this butterfly acts like a thin film, and whenever light falls on this thin film, there is going to be interference. When this interference takes place, we are able to see different colors from the different angles, and the butterfly looks so beautiful. This is again one more wonderful gift of the nature, where we can come across this interference phenomena, right? So these are some examples one can see the interference phenomena, and it is due to, in all these three cases, interference of light. Then, have you seen this? What is called the spider net? Definitely, all of you are familiar with this spider net. At each and every home, at some corners, you would have come across these things. But if the same spider net, if you see it in a sunlight, if the sun rays are able to fall on that sunlight, usually what happens, this we observe inside the home. But in some cases, you can see it, outside the building also, at some corners. If sunlight is falling on this spider net, you will be able to see wonderful color combinations from different angles. If you see from here, you get a different color combination, as you can see. If you see from this angle, you'll be able to see different color combination. If you see from this angle, you'll be able to see different color combination. Again, one more beauty of nature. So you can see here you'll be having different colors. That is again due to what? Due to the interference, the phenomenon of interference. That is, whenever the light falls on this spider net, this spider net, it acts like a film. It acts like a thin film. So when light falls on this, at each and every point, the light undergoes interference. Sometimes it undergoes constructive interference, sometimes it undergoes destructive interference, and we are able to see the beautiful colors of white light. Why we are able to see different colors? Because we know the fundamental property that white light is made up of 7 colors. So all those 7 colors you'll be able to see from the different angles. As you change the angle, the color changes. In the sense, interference is undergoing a different pattern at different locations. One more classic example where interference phenomena is observed in nature. If at all you have not observed this in sunlight, please do it whenever it is possible for you, right? Then So have you seen this thing? That is one more familiar phenomena. Those who are especially staying at villages. If you go to the pond nearby your village, ಕೆರೆ ಅಂತ ಏನು ಹೇಳ್ತಾರಲ್ಲ, ಆ ಕೆರೆ ಕಡೆ ಹೋಗಿ ನೀರು ಶಾಂತವಾಗಿರುತ್ತೆ. ನೀರು ಶಾಂತವಾಗಿದ್ದಾಗ ಈ ಕಡೆ ಒಂದು ಕಲ್ಲು ಹಾಕಿ, ಈ ಕಡೆ ಒಂದು ಕಲ್ಲು ಹಾಕಿ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಫಸ್ಟ್ ಏನಾಗುತ್ತೆ, ಒಂದು ಕಲ್ಲು ಹಾಕಿದಾಗ ಏನಾಗುತ್ತೆ, ಯು ಬಿ ಏಬಲ್ ಟು ಸಿ ದೀಸ್ ಪ್ರೋಗ್ರೆಸಿವ್ ವೇವ್ಸ್. ಒಂದು ಈ ಥರ ವೇವ್ಸ್ ಸ್ಪ್ರೆಡ್ ಆಗ್ತಾ ಹೋಗ್ತವೆ, ಸ್ಪ್ರೆಡ್ ಆಗ್ತಾ ಹೋಗ್ತವೆ, ಸ್ಪ್ರೆಡ್ ಆಗ್ತಾ ಹೋಗ್ತವೆ, ಎಲ್ಲಿವರೆಗೂ ಹೋಗ್ತವೆ, ದಂಡೆವರೆಗೂ ಸ್ಪ್ರೆಡ್ ಆಗ್ತಾ ಹೋಗ್ತವೆ. ಸೊ ವಿ ಗೆಟ್ ದೀಸ್ ಪ್ರೋಗ್ರೆಸಿವ್ ವೇವ್ಸ್ ಸ್ಪ್ರೆಡಿಂಗ್. So you throw one more stone in the still water, again the waves will start spreading in this direction, the waves will start spreading in this direction. So if you want to experience this, what you have to do is you throw the two stones simultaneously. I am sure you did these things in your primary days. Definitely all might have come across this. What you can see is the two waves here. One wave is coming in this direction, one wave is coming in this direction, and at this area they are interfering. This is again the interference of the two progressive waves. Interference of two progressive waves, which we call them as what are called mechanical waves. This is one mechanical wave, this is one mechanical wave. These two waves are interfering. When they interfering, when they undergo interference, what we get is we get a different combination of crust and trough, crust and trough, crust and trough, crust and trough will be obtained here. This is again one more beautiful example of interference. This is due to the interference of the so-called mechanical waves, where the waves are undergoing interference, right? If at all anybody has not practiced this, you please do it at your nearby places, and you enjoy this phenomenon of interference. What I can say is all of us have observed these things, but we don't know what is the reason behind this. We don't know the science behind this. Now we are able to understand what exactly the science behind these things. So as a student, you should have the sense of curiosity. Whenever something happens, you should ask always yourself, what is the reason for that? If you start asking those questions, then you will come to know what exactly happening, what is the physics behind that, what is the chemistry behind that, or what is the science behind that. So this is one more beauty of interference, where two waves are combining together, right? Then, so this is again, you can see what we have is we have a paint surface. This is a paint surface, a blue paint surface. So if you throw two stones simultaneously at two different locations, you can see the waves are spreading in this direction, the waves are spreading in this direction, and at this area they are intersecting. Means what? They're undergoing interference. They're interfering with each other, and they are giving rise to different combinations of waves in this area. One more example of interference which you can experience, the interference of light, right? Then this is one more familiar example. I'm sure all of you might have come across. Can you guess what it is? Yes, this is the phenomena which you will observe during the rainy season. Let's say during the rainy season on the road, if at some place an oil from a vehicle is fallen on the road, wherever the oil has fallen, at that area you'll be able to see this wonderful color combination on the road. During the rainy season, whenever a drop of oil falls on the road, that oil gives rise to this beautiful color combination. If you see from this direction, you will find a different combination colors. If you see from this, you will have a different combination. If you see from here, you will have a different combination. If you see from here, you will have a different combinations of light. What is this all about? This is again the interference. That is, this oil layer which has fallen on the road, it acts like a thin film. This oil layer behaves like a thin film. Once the light enters into that thin film, it undergoes reflections, and it undergoes transmissions, and these waves, they combine together to give the phenomenon of interference. Once it undergoes interference, we get these different colors combination on the road. When we observe from different angles, we see different colors. It is again due to interference of light, which is happening in the nature. and you can have a classic observation of this during the rainy season. If at all you have not observed, wait for a minute. During rainy season, you place a drop of oil on the road. Oil irutala. When the drop oil haki road mele, let the sunlight fall on that, and you can observe this wonder of nature, the phenomenon of interference, right? So then, I think this is a familiar case where all of you are experiencing these things in your day-to-day life. This is the CD which you use for many applications. If you observe the CD in a sunlight from different angles, even not only sunlight, even if you are observing it inside the home also, there's some light falling on it. You can see different colors from different angles when light falls on this CD. Why it is so? What is the reason behind this? Again, the beauty is the interference. That is, this upper layer of CD is basically a film. It's a thin film. So light is falling on this thin film from different angles. When it falls on this, it undergoes interference. It undergoes interference. What we get is the different color combinations from different angles on this CD. So this is again one more classic example where interference can be seen with the naked eye in everyday life. If anybody has not come across this, please experiment at home. It doesn't cost you anything. What is required is you require hardly one waste CD, which is for no use for anything. You take that CD and observe the different combinations of light at your home. If you have the more effect, bring it to a sunlight and you can see the beautiful color combinations on this CD, the wonders of interference, right? Then, so this is one more classic example of interference. You can see, I don't know how many of you have seen this bird, especially those who are staying in Uttara Kannada, like this Sirsi, Honavar, Bhatkal, Karwar district. They might have come across this bird. If you look at this bird from this angle, this angle, this angle, this angle, you'll be able to see different color combinations of this bird. Why it is so? Again, the reason is the interference. This upper layer of this bird, it acts like a thin film. When light falls on this film, what happens? The light undergoes interference. It undergoes constructive interference, it undergoes destructive interference, and we are able to see the beautiful color combination on this bird. From different angles, we get different combinations. This is one more beauty of interference which can be observed in nature. So those who have the a chance to see the birds nowadays, birds are not seen much, but they are still available in the rural areas, especially in the forest areas like Dandeli, Haliyal, Karwar, Bhatkal. These areas, those who are staying in Uttara Kannada, they can definitely watch this beauty of interference in nature, right? And then, so this is one more familiar example of interference. If you observe the front side of a camera, that is, it's a lens camera, not an ordinary camera, a lens camera. So as you can see, if you observe the front side of this camera, you'll be able to see different color combinations. So this front side of a camera, it acts like again a thin film. When light falls on this, in this angle, this angle, this angle, this angle, this angle, this angle, we get different color combinations because the light is undergoing interference on this a thin film of camera, and we are able to see the beautiful color combination on this camera. Again, one more classic example of camera. So from this, what you see is there are so many things which are happening around us, and there are every day we are observing these phenomena. Every day interference is taking place in so many places, but we don't know what exactly it is. We don't know whether it is interference or we don't know. We just see it and keep quiet. But think a while and try to understand the science behind that. So as you can see, there are so many cases where you have come across interference. Now, all these are all the examples of interference taking place in our day-to-day life. Means what? Interference is there in each and every part of our life, but we don't know it is interference. So from today onwards, you'll be able to explore what exactly it is and what is the reason behind that, right? Then, so So this is one more classic example of interference. So what we have here, so we have here one speaker which is producing a sound. We have here one speaker which is producing a sound. From this speaker, these are the waves. These are the waves coming here. From this speaker, we are having, the waves coming here. So the waves from this speaker and the waves from this speaker at one point, at this point in between, they combine together. Or in other words, these sound waves, they undergo interference. When these sound waves undergo interference, we are able to see the beautiful combination of sound. We get, a loud or a huge sound from these speakers. Why? Because the sound waves are undergoing interference. The sound waves are undergoing interference. When they undergo interference, we see a different combination of sound. We enjoy the music. This is the one more beauty of interference, where interference is taking place due to what? Due to the sound waves. This is a wave coming from this speaker, the wave coming from this speaker. They combine here at some particular area and they produce interference. The beauty of interference we are enjoying every day, right? Then I don't know how many of you are familiar with these things, or you have come across these things. This is what exactly the interference patterns we obtain in laboratory. That is, when we do the experiments at laboratory, this is the kind of a fringe pattern we observe in lab. As you can see, this is a red light, a red light, a red light, a red light. If you observe in between this red light and this red light, we have a black color here. So a red, a black, a red, black, red, black, red, black means we have alternative fringe patterns. We call them as what are called fringe pattern. Red light, black light, red light, black light, red light, black light, red, black. This is what is called a fringe pattern. These are what are called the interference fringe patterns. When you do the experiments based upon interference in the laboratory, this is the kind of fringe patterns we obtain at laboratory. If you observe this fringe pattern, we come to know that the light is not distributed uniformly. Means what? If everything is red, what it means? It's a uniform distribution. If everything is black, it's an uniform distribution. But here, some area is red, some is black, some is red, some is black, red, black. Means the light is not distributed uniformly. Or we can call what is known as something called non-uniform distribution. It is a non-uniform distribution. So this non-uniform distribution, we call it as what is known as interference. We call it what is known as interference. So one of the simple definition of interference is the non-uniform distribution of light is what is known as interference. Why it is non-uniform? Because if all of is red, then it is going to be uniform. If everything is going to be black, it is going to be uniform. In this case, what we are getting? We are getting some red band, some black band, red band, black band, red band, black band. So there is a non-uniform distribution. So this can be taken as a simple definition of interference. We say interference is a non-uniform distribution of light in simple terms, right? This is one example which you can come across in a laboratory. Then, so this is one more beauty of interference which you observe in a laboratory. If a college reopens, if you start doing the experiments, this experiment we are going to perform in this semester, and we are going to observe this beautiful fringe pattern, what are called Newton's rings. So what you can see here is, you can see these concentric circles. One is yellow, one is black, yellow, black, yellow, black, yellow, black. So alternative yellow and black, circular rings. These are the rings that are called Newton's rings. Because they are called Newton's rings because Newton was the one who explained this phenomena. Again, this Newton's rings are this alternative dark and bright circles. Some area is bright, this is dark, bright, dark, bright, dark, bright, dark. So we're having alternative bright, dark, fringe patterns. What is the difference compared to the earlier one? Earlier they were in a straight line like this. Now here they are circular. They are circular in nature. Again, this is what is known as the phenomenon of interference. It is due to the interference phenomena, we get this kind of circular rings in the laboratory. One beauty of interference are known as Newton's rings, right? So with all these examples, now you would have some idea of what exactly interference is all about, the day-to-day applications which we come across in our daily life, right? So with these pictures in our mind, now we'll try to understand what exactly interference is all about, how it takes place, what is the reason behind that, what are the types of interference. We explore all these questions one by one from here onwards, right? So now the question is, all these effects are due to interference. If they are all due to interference, then what exactly interference is all about? What is interference, right? So we'll try to explore this from here onwards. See, this is the man. This is the man who is responsible for demonstrating interference. A scientist, great scientist known as Thomas Young. Thomas Young is the man who demonstrated the phenomenon of interference for the first time in his famous experiment, what is known as Young's double slit experiment. I'm sure some of you might have come across this in your PU studies. What is known as Young's double slit experiment. It is this person, what is known as Thomas Young, who demonstrated for the first time successfully the phenomenon of interference, the so-called the wave nature of light. As you can see, he was born in the year 1773, and he is a famous British physicist. He has given so many contributions to the world of science, and some of them are what is called a wave theory of light. He is the one who successfully established the wave theory of light, and he is the one who did this experiment, what is called as a Young's double slit experiment, and successfully demonstrated the phenomenon of interference. And he is also known for what is known as a phenomenon called astigmatism. He is known for Young-Helmholtz theory. He is known for Young temperament. He is known for Young's modulus, which are come across this elasticity, Young's modulus, bulk modulus. So what is called Young's modulus, right? He was so popular and so a pioneer in his work. The scientists called Robinson and Andrew, they have described in their book the person Thomas Young as what is known as the last man who knew everything. He has been described as the last man who knew everything by the scientist called Robinson and Andrew in their famous book, which is published in the year 2007. So all this credit of interference goes to this person, what is known as Thomas Young. So you should know who is the scientist who has worked on this, and because of him, we're able to enjoy this phenomena in our day-to-day. We're able to observe it in our day-to-day, and we're able to see what exactly it is all about. What is known as Young, the Thomas Young, the man known for double slit experiment, or the man known for what is called a wave theory of light, right? Then let's look at the simple definition of interference. So what is interference? We say interference is a phenomena in which two waves superimpose to form a resultant wave of greater or lower or the same amplitude. Before trying to understand this definition, let's make it very simple. Just try to understand the meaning of this word. If in physics, if you understand the meaning of the word properly, it is as good as understanding the topic 50% correctly. You remember this. If you can understand the word properly, you can as good as understanding the concept very easily. What the word says, interference. What is the meaning of interference? Interference is nothing but combining two things, or mixing two things, or superimposing two things. Fair means what? Ference. Ference means combining. With what? Interfering means one from this side, one from this side. There are two things which are coming and they are interfering. So when the two things combine together, when they superimpose together, when they mix together, we get something else. We get something else. But what is combining here? It is the light from this side, the light from this side. These two lights are combining. They are superimposing. They are mixing. So when they mix together, they give us to something else. And that phenomena, we call it as what is known as interference. So in simple terms, we can say interference is nothing but the mixing or the superimposition or the combination or the, what do you call, the proper word, superimposition of two things. What are the two things here? The light waves. One light wave coming from this side, one light wave coming from this side, or a light going like this, or a light going in like this. So these two waves, when this wave and this wave, when they combine together, we get a resultant wave which is of a different nature. So this combination of two waves, we call it as what is known as interference. So what is interference? Interference is the phenomenon in which two waves are going to superimpose to form a resultant wave of greater, means when they combine together, we may get an increase in the intensity, or we may get a decrease in the intensity, or there may be nothing happening, right? So when you get a combination, this is the kind of wave we get. You can see at some place the intensity is increasing, it is decreasing, it is increasing, it is decreasing, it is increasing, it is decreasing, right? So when they combine together, the intensity may be more, or it may be less, or there may be nothing happening. So this phenomenon of light, where two waves are combining together, is what is called interference. Or in other words, we can say it is the phenomenon of a redistribution of energy. Look at this word carefully. The phenomenon of redistribution of energy due to superposition of light waves from two coherent sources. Two coherent sources. So we'll discuss these coherent sources a bit later. So we say it is a redistribution of energy. Why we are saying it is a redistribution of energy? Because if you remember in the previous slide, I have told you, when the interference takes place, we get alternative fringe pattern like this. So what we are getting, one bright, if you take it as a dark area, this is bright area, dark, bright, dark, bright, dark, bright, dark, bright, dark, bright, fringe pattern like this, right? So what's happening here? The energy is getting redistributed. Means at some area the energy is low, energy is high, energy is low, energy is high, energy is low, energy is high, energy is low, energy is high. Earlier, how it was? Earlier, when it was coming in the form of a light, in the form of a wave, the energy was distributed uniformly. It was distributed uniformly, means take it as a light in this way. So here the energy was distributed uniformly. Everything was bright, right? But when interference takes place, the energy is redistributed. Some is dark, some is bright, some is dark, some is bright. This is what you call it as redistribution of energy. Or in other words, we can also call this as what is known as non-uniform distribution. We call it what is known as non-uniform distribution of energy. So this non-uniform distribution of energy, whenever the two light waves they combine together, is what is called as interference. What is called as interference. So we may say it is a non-uniform distribution, or we may say it is a redistribution of energy, or we may say it is a superposition of two or more waves equal to greater or lower or same amplitude. These are some of the simple definitions of interference we can come across in any book. If you remember this, or if you understand this much of interference definition, is more than sufficient to have a knowledge of what exactly interference is all about, right? Then, so if at all you want to understand this interference thoroughly, we have to have the knowledge of some basics. So to know what exactly it is in detail, you have to have some basic knowledge of wave nature of light. That is, without this knowledge of this basics of light, you cannot understand the concept of interference properly. So what are these basics? What we're supposed to understand? What exactly a wave is? What is a crust? What is a trough? What is a wavelength? What is a frequency? What is a, all these things are the basics to understand this, interference thoroughly. I think these basics we can discuss in probably the next class. So right now, if you have any questions, I want to take your questions right now. So if you have any questions,